Most of us have heard of the Fibonacci sequence 1, 1, 2, 3, 5, and so on, where each term is the sum of the previous two. Additionally, you probably have heard of the golden ratio, phi, defined as the ratio of the sides of the rectangle, where the long side over the short side is equal to the sum of both sides over the long side. A slightly lesser known fact is that dividing consecutive terms of the Fibonacci sequence gives better and better approximations for phi. Let's look at why that's the case. Let's first consider a golden rectangle with long side phi and short side 1. The defining property of this rectangle is that phi is equal to phi plus 1 over phi, which can be quite easily rearranged to show that phi is 1 greater than its inverse. Next, let's consider some part of the Fibonacci sequence, where we have the three terms x, y, and x plus y in a row. Let's consider a rectangle with sides y and x, whose ratio is roughly phi. Adding a square of side length y constructs a new rectangle with side ratio x plus y over y, which can be arranged to x over y plus 1, which is roughly equal to 1 over phi plus 1, or phi. As for this being a better approximation, there are two cases here. I'll explain only one as the other is nearly identical. By inspection, we realize that y over x alternates from being larger than and smaller than phi. Suppose it is larger than phi. This means that x over y is less than 1 over phi. Let the positive differences be d1 and d2. This can be arranged to show that d2 is less than d1. And we're done. QED.